loss probability versus implied utilization and the number of servers. In this segment, we're going to look at the loss probability and how it depends on implied utilization. And so this chart shows you a few lines for m equal 1 to up to m equal 20 servers. And you see here the implied utilization is increasing from very low to even higher than 1.1, right? So this is where the capacity is insufficient to serve all the demand. And I hope you see, right, as you increase the implied utilization, the loss probability, right? So the probability of all servers being utilized is increasing. And the most severe increase is when you have a very small number of servers, right? And when you have a larger number of servers, like 10 or 20, we can actually cope with a reasonable utilization, like, for example, 50, 60%, right? With a very small loss probability. So we had a case of, if you remember, 3 servers with about 22% utilization. We had a small percentage of lost demand, but when we increase it to 50%, the utilization, implied utilization, then the probability of all servers being busy increased significantly. So as before in the waiting line models, we can see some economies of scale here because, right, when you have only one server, even a very small utilization, when there is no buffer, creates a significant probability of losing demand. And so large percentage of demand can be lost, 20% of demand with 20% utilization. But when you have, let's say, 20 servers, you can work with maybe 60% utilization and have a very small fraction of lost demand. So there is economy of scale if you increase the number of servers with the same implied utilization. So having the same proportion of demand to capacity, you will actually be able to achieve, satisfy more of the demand and lose less demand as measured as percentage of demand.